In this video, we are going to be looking at multiplying vectors by scalar quantities. So let's just say I have this vector AB with the column matrix 3, negative 2. So that's 3 units to the right and 2 units downwards. So here we can see 3 units to the right, 2 units downwards. So I have my drawing of the vector AB. So let's just say I have this vector PQ, where PQ is twice AB. So this 2 would be scalar quantity and AB would be the vector quantity. So I'll be multiplying this vector AB by this scalar 2. So that'll be equal to 2 times the column matrix 3, negative 2. So that'll be 2 by 3 and 2 by negative 2. So basically I multiply this 2 by this 3 to get 6, and this 2 by this negative 2 to get negative 4. So 2 3s are 6, and 2 by negative 2 is negative 4. So I'll have my vector PQ being equal to the column matrix 6, negative 4. Now let's draw that vector PQ. So this would be my starting point where the tail of the vector would be, which would be P, and I'm going 6 units to the right and 4 units downwards. So 1, 2, 3, 4, 5, 6, and 4 downwards. 1, 2, 3, 4. So this is where Q would be, which is the head of the vector. So now that I have the drawings for the vector AB and the vector PQ, we can see that the vector AB and the vector PQ have the same direction because the arrow is pointing the same direction. Also, we can see that these two vectors are parallel. The only difference is that the length of AB is shorter than the length of PQ. And remember, the length of the vector is the magnitude of the vector. So PQ has a bigger magnitude than AB, but they have the same direction. So one thing that we can notice from this is that for parallel vectors, one vector would be a scalar multiple of the other. For example, the vector PQ is parallel to the vector AB, and that's because PQ is a scalar multiple of AB, because to get PQ, we multiply AB by a scalar, which is 2. Now here we have the vector Mn, and Mn is equal to negative 2 times AB. So this time we are multiplying the vector AB by a negative scalar, which is negative 2. So that will be negative 2 times the column matrix 3, negative 2. So if we multiply negative 2 by 3, we'll get negative 6. And if we multiply negative 2 by negative 2, we'll get positive 4. So Mn is represented by this column matrix with negative 6 and 4. Now let's draw the vector Mn. So I'll let the tail of the vector Mn be at this point. So this is where M would be. And from M, we'll be going 6 units to the left and 4 units upwards. So that'll be 6 to the left, so 1, 2, 3, 4, 5, 6, and then 4 units upwards. 1, 2, 3, 4. So this will be N, where the head of the vector would be. Now again, we can see all these vectors are parallel, but the vector Mn is in the opposite direction of AB and also PQ. So multiplying a vector by a negative scalar would still give you a parallel vector. As you can see, Mn is still parallel to PQ and AB, but multiplying by a negative scalar, direction of the vector would change to the opposite, meaning Mn is in the opposite direction of PQ. Now Mn and PQ have the same magnitude because Mn is negative 2 times AB and PQ was 2 times AB, so they both have the same length, which is the same magnitude, but they have opposite directions, and that's because of the negative scalar. So here I have this question that we want to determine whether the vector AB with the column matrix 1, 3 is parallel to the vector XY with the column matrix 5, 15. Now, just by observing the column matrix of XY and AB, we can see that the column matrix of XY is 5 times the column matrix of AB. So I'll say that XY is equal to 515, which is equal to 5 times 1, 3, which is 5 times the vector AB. Therefore, the vector xy is a scalar multiple of the vector AB. Therefore, the vector xy is parallel to the vector AB. So once you can show that one vector is a scalar multiple of another, that is sufficient to show that the two vectors are parallel. So I have, since the vector xy is a scalar multiple of the vector AB, the vector xy and the vector AB are parallel. Now I'd just like to go back to the vector AB that we started with, and let's work out what is negative AB. So that will be multiplying the column matrix 3, negative 2 by negative 1. So having this negative sign outside the brackets implies that we are multiplying the 3 and negative 2 by negative 1. So negative 1 times positive 3 would give negative 3, and negative 1 times negative 2 will give positive 2. So now let's draw this vector negative 3 and 2. So negative 3 will be 3 units to the left, and 2 will be 2 units upwards. So I'll let the tail of the vector be at this point, and then I'm going 3 units to the left. So that's 1, 2, 3, and then 2 units upwards. So that's 1, 2. Now we can see that this vector has the same length as the vector AB, and also that these two vectors are parallel. But these two vectors are in the opposite direction. So if I were to keep the B down here and the A up here, this vector will be pointing from B to A. Therefore, negative AB would be the same as the vector BA. So therefore, negative AB is equal to BA. So what we can observe here is that when you multiply a vector by negative 1, you switch around the letters. So negative AB, you switch around the letters and get positive BA.